All right. Thanks everyone for sticking around for my lightning talk. My name is Adrian Maurer, and today I just wanted to do maybe a bit of a thought experiment because we got a lot of these great new platforms and these, and we also have all these traditional patterns that we used in our current architectures and our systems. And I wanted to see if we could kind of like build on these and put them all together, combine them, and try to see how those work on a serverless platform. I'm going to try to tie in a lot about what we heard today as well. So let's get started. A little bit about me. I work for CGI for the Emerging Technology division. Mostly what I do is I try to work around organizational performance problems, and I develop architectural solutions for our clients. And this was when I started reading about serverless and then trying it out, I thought there are really good patterns here on how to fix some organizational patterns, and that's kind of how I started this talk. But being here today, it's a very technical audience. I thought I maybe just focus a bit more on the architecture side of things. So what did that look like? We saw a lot today about we have an event-based system when we were talking about serverless. So I wanted to use this as our foundation, and in my proposed architecture here, what I wanted to start building upon is this immutable event store. So this is our queue system that stores every event ever in the history of our system, and this is never changing. And this is something that all parts of the other organizations can publish and subscribe to with their own services, and they could build their own versions of the truth on top of that. So we have here, a bunch of different services building their own aggregate views, and from there they have their own services on top of that. So from what does that mean? So we got check event streaming, cool, and we got domain-driven design. So our APIs are kind of well-defined here in this platform. For all the enterprise guys out there, this is not an ESB. This is just a dumb queue. And based on what we've seen today, this can be Kafka, Kinesis, Azure's Event Grid, lots of great ideas I heard about today. And what does that look like in terms of requests coming in and requests coming out? I want to talk a bit about the CQRS pattern, so command query responsibility segregation. And what that really means is you split your writes and your reads into two different parts of your service, or you have a separate service for either. And commands are not the complete state, right? It's an append like a +1 or a debit or credit on your statement. When you put them together, you kind of get a full state. Talking about our event gateways and our REST gateways, traditional way you'd get an HTTP post. We convert that using our gateway into an event that we publish to a specific topic that a bunch of teams or services can subscribe to, do something with it, publish an output back to the stream, and get anyone else can kind of subscribe to their own service or sub-service topics and do more actions on those, and then return some sort of state back to the original requester. And on the get side, you just standard REST get request and pretty normal from there. So a really good way that you can implement this on the client side is actually if you've used React or Redux. It's kind of a client-side event-based single source of truth implementation for React. Every time you trigger an event in Redux, you can kind of trigger these commands and you could keep your state separate. You don't really even need to return a result back to your client. You can just keep them separately, and you'll be able to query the state at a different time if you needed it. So some solutions that we saw today, Fazlang from Keith is standard lib for a REST gateway. Attach your functions and your streams through there, and then you get all that nice other functionality with a contract system, or your parameters to kind of validate your request. Event Gateway, similar idea, but by the serverless guys they've announced last week. Another cool product to use. So check, we got our command query segregation. Next, let's start making this more functional. So Adib touched on this a little bit in his last talk. So how do we kind of make our services? Let's kind of lift the hood on one of these things and see what we can do. So if we treat our services as a set of these pure functions, the way it was described in the last talk, with Reactive Manifesto, you can kind of compose functions if they're pure. And what they mean if they're pure is you have a function that takes the same input, will always give you the same output, right? It doesn't mutate state. It's just in and out. Subscribe to a stream, get some data, publish something out, and away we go. And ideally, we would want to use a strongly typed language. F-slang actually really helps with this. In the case of using like Python or JavaScript, I know Scala is supported, so if you're not going to use something like that, maybe just use Scala, because it really makes this kind of pure functionality a lot more simple to implement. And of course, we could deploy those to our platforms like StandardLib, and then we saw a few here like SAM, AppLogic. AWS also has step functions, which we can do, and Pivotal Cloud Functions would be another great system for this. Right, so we've checked all these boxes. We've done all our patterns that we've seen in the past, and now we've deployed this to our serverless architecture. Let's talk about something a little bit more complicated. So, but before that, one other cool thing you could do in this immutable event store is you have these bunch of topics with all your immutable commands. If you ever wanted to stand up a new service and see the data of it, you could essentially replay that, right? Replay it from the beginning in history, and just pop on a new service to that, start publishing and subscribing to that, and away you go. And another great thing that I saw just now is maybe you could kind of orchestrate all this with that whole Skates tool. All right. Okay, so the cool part. So this is what I really want to get to. So talking a little bit about reactive and being functional and being able to compose our functions together to make the service. If we take that one step further and start looking at some algebraic properties of our pure functions in our type system, we could kind of look at something called monoids. I think this is similar to how Adib was talking about monos and fluxes. Same idea here. Monoid is just a set of that's closed under an associated binary operation and has an identity element. So an identity element, right, in algebra, it's like having 0 in an addition function. It will do nothing to your system. So if you kind of get where I'm getting at here, if we kind of treat some of our commands as identity elements in our system, we could publish a new version of our functions to our serverless platform and start running our functional and integration tests, making sure that maybe we tag it with a header saying this is an identity element, and then we run it through the system. The system behaves the way we want to. We assert on specific inputs and outputs on the stream, and we should be pretty satisfied that our system is working. And then we go live with that immediately by just hooking that into the gateway, right? And then all your requests are then flowing there. So this is a really good thing that people are talking about, using serverless to reduce runtime costs, right? We want to maybe just have less environments, just an idea, play with. And you might have to have some flagging and stuff, but the whole idea of being functional and being composing is try to avoid flags and things like that. But when you're integrating with third-party applications, that might not be an option. Yeah, and there's a thank you. If we have time for Q&A, no? Okay, so, all right. Yeah, I'm also hiring. We're playing with these ideas, and we want to kind of deliver this, so feel free to talk to me after.
Big round of applause for Adrian. Thank you.